So I'm going to talk about work that is currently being done with me and a couple of other people, and it is still in the making. So what I'm going to present is not all wrapped up and nicely, and it's not all great data sometimes. I will do my best to show you what we did and why we did it. It's work done together. It started with an MSc project by who is now working with me, Nathan Pearson, and my colleague Martin Jötner, who is an eye tracking person and now interested in visual perception. And we got also some huge help from another MSc student, James Hughes, who is a bit of a Photoshop guru and who helped us create face stimuli. We have a little bit of funding now to do a bit of more work on this. That's why I mentioned the Experimental Psychology Society, EPS, which supports us. So I would like to talk a bit about the psychology of facial disfigurement and then present data from 2 experiments that we have done about viewing and attending to disfigured faces. And I'll then try to wrap up and draw conclusions from what we think is a useful avenue to pursue this research about the differences in processing between disfigured and non-disfigured faces. So actually I rolled into this project a couple of years ago when I had a final year student coming to me with an interesting paper about facial disfigurement. I had never actually intended or to do this kind of work, and I realized it was actually a very little researched area, and so it's a huge cliche, and everybody in psychology knows that faces are really important in everyday interactions. So we communicate through faces and to faces, and we extract a lot of information from the person characteristics, emotions, personality. It is worth reiterating this because there is such a vast range of information that we extract from it, and it is interesting, useful to realize when we can draw conclusions about people's intentions, and whether or not these conclusions are right or wrong, we still can do them and to make them in a quite fast. And so the way a face looks can have an influence on the kind of inferences that observers draw from it. And of course, if you are good looking, and then people might find you more friendly or clever, successful, etc. I don't need to tell you who these people are, but they sort of are, for many people, kind of a typical example of people who are successful, and they owe it in part probably to their looks, to what got them to life. Whether or not that is always true is a different matter, but that is the perception that people have. And if you are afflicted by a facial disfigurement, such as this person here, who has been this gentleman who, as a war veteran and burns victim, life and many aspects of life are becoming a bigger challenge and persons with facial disfigurement, they can face significant challenges in life, and they can overcome it too. Because I didn't know much about facial disfigurements, and I went to this website called Changing Faces, and there's quite a lot of people in the UK who have a significant disfigurement to the face. Not everybody, not all of these people may suffer to an equal extent, of course, from it. But I want to show you this because it shows a bit that there are also a variety of conditions and causes that can lead to facial disfigurement. And it seems like if you think of all of these people have to interact with others, and if they have a severe facial disfigurement, they will have significant challenges. So there is actually a kind of question of how do we interact with such people. Because facial disfigurements come in such a varied types, it is difficult to sort of classify them. But I sort of, from a layperson point of view, you could have on the one hand local, relatively localized disfigurements that such as burns or scars, and they could often be seen as sort of features. So when the disfiguring features is being hidden, then the face looks otherwise quite normal. On the other hand, there can be often more serious medical conditions that can lead to significant alterations to the structure of the face. Luckily, these medical conditions are quite rare, but they then cause a disfigurement that is affecting more the configuration in the face, the structural, and that is then spatially extended and has often more deeper causes. Literally, for instance, people with bone deformities, and or with large, extensive skin conditions. So I will be talking more about the local feature-like disfigurement. There are important psychosocial consequences to facial disfigurement, and these are well known and well documented. In virtually any situation in which a person with a disfigurement would interact with others, and where that other person would draw inferences from them or respond to them based on their visual information from their face, there is a challenge, or there is the possibility that the disfigurement can negatively affect the observer's cognition, attitude, or behavior. And we call this avoidance, stigmatization, and discrimination. And there's quite a lot of research on this area. For instance, I found a paper in which the participants viewed interviews with a person who had a very small scar or blemish on their face, on their cheek, and they were videoed during a simulated job interview. The participants rated the applicant in the video who had a scar, even if it was a very small scar on the cheek. They rated them as more negatively, and interestingly, they also remembered less well what the person said. We were also looked at differently. So in that article, they did eye tracking, and the measure of analysis was quite rudimentary, but they were able to show that people looked significantly longer at the side of the face so there was more attention to disfiguring features, and apparently that seemed to somehow feed back into a poorer memory of other information about the applicant. A more methodologically interesting study that I found is this study by Ryan et al., who did an experiment in which participants were shown a video, and in which an actor was handling objects, and these objects were also placed in front of the participant. And the task of the participant was to imitate the actions that they saw in the video. For instance, if the actor was taking up a cup, and then putting it to his or her mouth, and the participant had to imitate that action to the best of their ability. And it was sold to them as a kind of imitation game. Interestingly, so when the actor simulated disease, for instance, sneezing, or when they had, for instance, a birthmark made on their face, so simulated onto them, the level of accuracy that the participant showed in the imitation dropped significantly, and dropped more so when the contact with the objects that they had to handle was more intimate, if you like. So most participants were okay in handling objects when the actor simulating a disease or a disfigurement handled the object with their hands or brought it to their head. But when they brought it to their face, or when they were asked to put it to their mouth, then the accuracy of the imitation dropped significantly. So observers avoided contact with objects during this imitation, and that's quite an interesting finding that seems to indicate that people that people take sort of a distance from the people process the disfiguring information and then respond to it by avoidance. All of these studies looked at here at handling objects and at behavior. In this experiment by Ackermann et al., this is one of the few papers I found in which the effect of disfigurement on the observer's attention is being measured. And in this experiment, a dot probe task was used. So you see a face, and afterwards a dot comes up, and the participant has to indicate the location of the dot. The face was always irrelevant, and some faces had a skin discoloration photoshopped onto them. Participants' attention was captured more by the task irrelevant face when it contained a disfigurement, so that people were slower in localizing the dot probe. And at the same, so that indicates that the faces that had a disfigurement attracted attention more than the faces without a disfigurement. In a subsequent experiment, these authors did a memory game. I don't know what the name's called, but you have these cards on the table with objects, and you have to turn two cards and see whether they match. Yeah, they had that game, but then with faces, and they tested memory for disfigured faces and for normal faces. And their hypothesis was that people are more likely to confuse faces that have a disfigurement. And they found that memory was indeed poorer for that, so in that game. This is one of few studies that looked at the perception and the cognition or the perception of disfigured faces by observers. And the aim of our experiments was also to look into this area, because if observers behave differently, what is the cognitive basis for this response? And also in many studies, including the ones shown here, the observers who were shown the disfigured faces were often primed in some way to pay attention to the disfigurement. By, for instance, here in this experiment, the participants who showed the effect of the distractor face with disfigurement, they had been primed to be disease sensitive. Because prior to the experiment, they were shown a slideshow about disease and with images which was used to enhance awareness of that. But they had already a cognition of, or they were already prepared to think more about that. But what you would like to know is actually how people approach these phases without any precognition, and also in situations, for instance, where the phase is not, or where the task does not necessarily relate to judging the phase. So we looked at how observers process disfigured phases, and how they view them and how they attend to them. So my first experiment, we looked at attention to facial disfigurements. So it is known, and there is quite a lot of research on it, that faces and salient features, they capture attention, and the visual search literature is full with papers on, for instance, a singleton non-targets attracting attention, capturing attention, but also there is quite a lot of evidence that faces among other objects, especially are detected very effectively and efficiently. So faces may be detected earlier than others. So we asked if a face containing a disfiguring feature, could it capture more attention than a face without a facial disfiguring feature? If yes, then attention to a task-irrelevant distracted face might interfere with performance to a target non-face. So we asked these questions, and in asking these questions, we compared the following condition. So we compared observers' responses in a task in which a normal face and a face were presented a face that had a simulated disfigurement. And so the hypothesis here is that a face with this disfigurement could capture attention more than a face without. If you think about people avoiding contact with disfigured faces, and you might also have an alternative hypothesis to say that perhaps they want to spend less attention to it, and they wouldn't spend more attention to the normal face than the disfigured face. A second question that we asked was when we were making these images was, okay, you could have features. There are features and features. So we have here a feature that is seen by many people as part of the face. It is photoshopped in such a way that it really looks like this person has what we intended to be a port wine stain. But you might also, for instance, think that it is a kind of burn or something. So these are features that intrinsically may be part of the face representation that people build. On the other hand, we could also use features that are not part of the face and that are what you could call accidental. They are simply there because they simply obstruct the view from the face. So we also created photographs in which a face was partly occluded by this rectangular feature, which partly overlapped with the background. So the idea is here that here you clearly perceive and acknowledge that this feature is not part of the face, of the intrinsic structure of the face. Well, here it is. And we had a hypothesis of whether, so if people are more sensitive to disfigured faces, might the interference that you get from disfiguring features be bigger when these disfiguring features are really seen as part of the face? So more interference here and there. We used a task, like I said, we wanted to use a task in which the faces were not relevant, because we were interested in looking at at covert visual attention. And we used a spatial cueing task in which attention was cued to the left to the right of the monitor of the screen, and in which people then subsequently had to discriminate a pattern that contained the letter T upright or upside down. Sometimes a face was being shown alongside the pattern. The face could be normal. It could be what we call disfigured, or it could be occluded, having the accidental feature. And we had finally also a baseline condition in which the pattern was shown by itself and there was no feature. And this is what happened during a typical trial. So the two boxes appeared, and then an arrowhead appeared indicating the likelihood indicating the location of the target. The target pattern appeared on 80% of the trials in the location indicated by the cue. So people were strongly encouraged to direct covert attention to the box indicated by the cue. And then we had the pattern coming up on 80% of the trials. On the valid trials, the picture came up and then a face appeared in the other box, or the pattern appeared in the other side and then the face appeared in the location indicated by the box, by the cue, and people then responded. So we didn't invent this task. So this is really a typical post-Merck queuing task. We took our inspiration from another paper that I'll mention, in which a very similar task was being used, and in which also faces were being shown. So we had so the distractor conditions, the face conditions, were equally likely, and we had left and far right visual field presentations of the face, and the disfiguring features were presented were added to one side of the face only, so to the left or to the right. So we were interested also in looking for might there be any spatial biases. Like I mentioned, the paper that we based our task on is a study by Sui and Liu, who published in Psychonomic Bulletin and Review in 2009, an interesting paper in which they did use the same task, but they used as faces attractive and unattractive faces, and they found from their analysis that attractive faces seem to show more interference. So the discrimination of the target pattern was slower when there was a highly attractive face on the other side. So we sort of took that up as well, because we had gathered a face database from several sources. There's a Glasgow and familiar face database, and there's a database from Holland that we used, and we showed the 20 most and 20 least attractive faces from a pool of 200 over faces. And these faces had been first rated for attractiveness, and we chose the most and the least attractive faces. We asked if attractiveness captures attention, like in the Sui and Liu study, then you might expect interference from attractive faces when they were normal. But what would happen if you would add this disfiguring feature? So you could then expect that interference caused by the attractiveness, by the beauty of the face, could actually be reduced because of the disfiguring feature relative to that of normal faces. Okay. So here are the data. So in our experiment, by the way, we verified that people kept their eyes centrally by measuring the eye movements, and this was simply to measure the compliance, that they were really fixating centrally, and that any attention shifts were covert. I show here the people's responses to discriminating the target pattern in the presence of a normal, disfigured or occluded face, and when these faces were in the normal way classified or rated as highly attractive, highly unattractive, and there's then the baseline in which no face was shown. So any interference would be shown in the form of slower reaction times to when faces appeared, so to the attractive and unattractive faces relative to the baseline. We found very little evidence for interference, much to our surprise. So the highly attractive and highly unattractive faces did not show any differences in compared to one another, neither compared to the baseline. In general, the only effect we found was that people were generally slower in responding to the target pattern when it appeared in the opposite location. But there was little indication from distractor phases on valid trials. Also, the presence of the feature, so needless to say, if the presence of the face itself did not make a huge difference, the presence of the feature did not make much of a difference either. Here we look at accuracy. We get a very similar pattern. So with no significant effects. The error bars are here the standard error of the means. So I should actually have plotted confidence intervals, and these will be very sizable, and it shows there is a lot of variability and there was very little interference. So we showed, in fact, paradoxically, you will see here that there is slightly more, like a higher accuracy towards target discrimination on invalid trials when there's a attractive normal face. But these are effects that are difficult to interpret according to the hypothesis in terms of the hypothesis we had. So two things then here. We found little evidence for attention capture by distractor phases overall, and that was a big surprise to us. So neither the presence of a face nor the presence of a disfigured occluding face caused interference. Attractive faces did not cause interference either. And this contrasts with other reports. Beauty may be difficult to ignore. This is sort of the only paper that uses that kind of paradigm in which that effect was reported. And we noticed that there are substantial differences in the stimulus design, and especially in the stimulus parameters, such as stimulus size, that made us wonder how much of an effect there would be. When we asked the participants, however, if they saw anything about the faces, and all of them noticed that some faces had features on them. Of course, because sometimes they were bright looking at them, or they had covertly attended to them, and they thought they had burns. Some participants reported that some faces looked unhappy, which is interesting because we had actually only neutral expressions. So in the second experiment, we looked at explicit visual exploration methods. So if we didn't find reliable evidence for covert attention being influenced by facial disfigurements. Can we find this when we use an overt attention task, where you explicitly explore faces? So we recorded here eye movements to probe the pattern of information intake from the face between normal and disfigured and occluded faces. So we asked, do observers look differently at faces when these contain a disfiguring or occluding feature? And we looked at scanning paths of initial fixations to the face and at looking times or gaze duration. That's the amount, the time spent looking at a face, including fixations as well as eye movements. Observers were asked to rate the face for attractiveness. Here we made the task also relevant. We had to ask something about the face, and we thought initially we come up with like symmetry judgments, but we eventually decided to try out for the attractiveness, which would also allow us to look at whether disfiguring versus occluding features had any different effect on ratings. In order to trigger people's exploration of the face, we presented them in the periphery of the visual field, and they had to make an explicitly, they had to move their eyes towards it and then explore the face. So basically, the participants were looking centrally, and then a face appeared for 2 seconds, and then they explored it and gave their rating afterwards. Here I present data that show the amount of time spent on different parts of the face. So we divided the face in four quadrants, upper and lower half and left and right half, and we measured the gaze duration. And these are the confidence intervals, and we found that for left side and right side disfigurements, there was an interaction between the upper and lower half and left and right side of the area of the face. So the participants spent more time looking at the lower left half of the face than at other parts, and that is shown in the interaction the left between side and upper, left and right, and upper and lower. This interaction was actually smaller when the face contained a feature that appeared on the right side. So it seemed that there was some kind of bias towards exploring or spending more time on the left side here. When we looked at faces that contained an occluding features, we found generally the same pattern. Again, an interaction between left side and right side of the face area, the left and right half of the face, together with upper and lower half. So again, the most time was spent looking at the lower left half of the face, and that was that was the area, of course, where the feature was. If you look at the right side, however, there was slightly less time spent on that side, and the interaction was actually smaller than here for the left side. So we seem to have a kind of bias more towards exploring the feature when it appears on the left half of the face and on the right half. I try to look at scan paths, and I am still learning from eye tracking, because this is the first eye tracking study I did. But what we did was I tried to convert the fixation locations into coordinates, and that indicate the proportion of the image that is being looked at. So 25 is 25%, if you like, of the image width, and then the 0 is the center of the image. And I overlaid this just for illustration, and the first 7 fixations are being shown here in the location of relative to the reference frame, where they would appear together with their confidence intervals. And this shows a bit where the succession of fixations that people explored in the beginning of the trial. People made an average like 10 fixations. We chose for the ones that had the most amount of data that were present, that most people made at least 7 fixations. So the scan paths interestingly show also kind of spatial bias. So if you look at the left side, this disfigurement, the fixations were more pronounced towards going away from the midline of the image, while for the right side disfigurement they appeared more towards the center. In other words, what this seems to indicate is that people looked more towards the location of the disfiguring feature, or at least in the area in which that feature appeared, compared to when the feature appeared on the right side, in which they stayed more towards the midline. So when the face contained a left side occluder, there was again a relatively strong spatial bias towards the left to looking at it, which was less strong when the feature was on the right side. These effects occurred similarly for left and right visual field presentations. So because you might think that, okay, because if the face is in the left visual field and it is on the left half of the face, the eyes are more likely to land there first because it is a shorter distance. We still see that bias and that lower. So for normal faces, for instance, you see the eyes going actually. So the first fixation, the people make a corrective movement, it appears, because they sort of travel from further. So if you look at left side, disfigurements in the left visual field or in the right visual field, they still look more in the left side of the face. Yeah. So the effect was not due to the location of the face in the visual field, and we found that's similar for the occluding feature. So here, left side bias, and for right side disfigurement and right side occluder, we found more central bias. In general, we looked also at the ratings. The attractive faces, the faces that were judged in the pilot study as being highly attractive, suffered in the ratings from the addition of either feature. So the ratings went down. I don't have the data here on the slide, but they just went down, and there was no difference whether the face was disfigured, either the disfiguring feature or occluding feature. So there was, and for the unattractive faces, the ratings did not go down as well. But the important thing is here to notice that the face attractiveness was not differentially affected by the presence of the feature, which made me then think actually that asking the question of rating the face is quite it is not always clear what you are asking of the participant, because some participants may interpret this as judging the quality of the image, or it is. So we are doing a new study in which we are adding to people, telling people like, don't look at the quality of the photograph; it's really the face. Yeah.
So did subjects ask about the disfigurements and how that's supposed to weigh in with their rating? Because that's a really obvious thing, right? You're asking
they didn't ask. No.
Okay, that's.
We did tell them some faces will have a feature on them, but you are to judge the attractiveness of the face. They didn't ask much else about.
Because I can imagine being a subject in the experiment, and
yes.
you're asking me to rate faces, and all of a sudden faces pop up. Some of them are attractive, some are not. Some of them have disfigurements, some
yes.
don't. And all of a sudden, I would think I was in a social psychology experiment. Like, what the hell are they looking at? And I would probably do weird things like maybe not look at the disfigurement, or
yes.
right. I mean,
yes. People were looking at this disfigurement. It does show. We had one participant, which we say that we did not include, who continuously during the experiments kept looking at the center of the screen, never looked at the faces. That was, or went there and went back. It was a non-compliant subject in that respect, who was not following. Well, was not sort of looking at the faces in order to make a judgment. But yeah.
oh, well, one other comment. It looks, just looking at these scan paths, it looks like most of the effect is showing up in the initial saccade targeting, right? So
yes.
it's influencing where they initially land, and then from there the eyes are jittering around a little bit. They're probably sampling information, but the manipulation, left versus right occluder, seems to be mostly affecting that initial fixation location, and
yes.
that was also true of the other
yes.
conditions as well.
Yes. There are other things you can, it's like how that would be the first saccade latency, or the time it takes to actually move towards the face. If you have covertly detected that it is an unattractive face with a disfiguring feature, might you be slower in saccading there? That is something I should probably be looking at as well. I'm open for any comments on this. Just to summarize here, so observers' overt attention was biased towards locations that contained the feature, and more so to the left than to the right side. When scanning the literature a bit on facial disfigurement, I came across a paper in some medical journal where observers rated photographs of patients who had a unilateral cleft lip, and the ratings of the severity of the disfigurement were actually larger for photographs that had the disfigurement on the left side of the face rather than the right side of the face. That's the only paper I find that is a bit of a bias that shows a bias that is similar to the bias we observed here in eye movement. So the presence of a disfiguring feature tended to draw initial fixations, but the type, the nature of the feature did not appear to change the dynamics of the scanning pattern. So we saw a perceptual bias within the face, and that has been reported before I think in emotion judgment studies where scanning paths are also biased towards the left half of the face. We found faces containing a salient feature, they seem to draw attention when you are during overt attention. At least we found evidence for that during explicit visual exploration of the face. the nature of that feature, however, did not further qualify this effect. I think one criticism of our own work, I think, is that maybe the difference between an accidental and a non-accidental feature may come out more clearly depending on the task instructions and the goal or the task set, such as in the other studies like from Ackermann, where people were primed to think about a disease and then showed an attention effect towards disfiguring features. When we presented task-irrelevant phases, covert attention did not appear to be affected by the presence of disfiguring features. And this within spatial bias may further influence looking behavior, and that may be one of the factors that ultimately lead to people's responses and ratings, the information intake that people take from their looking may then further influence the judgments that they make. So we did not. So what we here is a slide about what we didn't do and what we want to do. We did not yet study in detail the consequences of a different scanning pattern for behavior, such as recognition, for instance. And we are currently looking at recognition memory, incidental and intentional, for faces containing salient features. And we do this with faces, with a new set of faces, and they are black and white faces. So we use race as a factor, and we have manipulated the faces to simulate a depigmentation of the skin, which is known as vitiligo. Maybe you've heard of it. So in a white person, it shows up as white patches, actually. But in a black person, for instance, vitiligo is a very serious, can cause a very salient disfigurement. And we are presenting these faces in a judgment task, and then people have either an incidental memory or an intentional memory task. So they have to make all new judgments, and they either know or they don't know that they have to remember the faces. We ask them to what extent scanning patterns correlate with the likelihood of correct recognition. For instance, a scanning pattern during the test, and you're looking at the face and you don't make a judgment. Have you seen this face before? Are disfigured faces processed differently? There is another way in which we can test it by looking at, everyone familiar with the face knows that normal faces are seen as to be processed in a configurable or holistic manner. So the configuration of the face is sort of is the information that forms the basis for the face representation. The opposite, or the information processing wise, the opposite of that is a feature-based processing strategy. And one could hypothesize that the presence of a salient feature may actually reduce the efficiency of the configurable extraction process. So, and there are ways of tapping into this configurable processing by measuring the effect of, say, face inversion on face recognition, and combining this index of the face inversion effect, combining this with the manipulation of having disfigured and non-disfigured faces. And that's something we would like to do, and we are planning to do in an EEG study in graphs. So we have in the past looked at ERP evidence of face configurable processing, and we have recently done work in which we found that this index of face configurable processing, this ERP index, can actually be modulated by the social categorization of a face as being part of your own group or part of another group. So when you're looking at a face that is labeled as being part of your own group, or a face that is your own race, or something that is indeed yours, then even at relatively early stages in visual processing, one can see a modulation of this configurable, of this index of configurable processing. We would like to use this technique. So basically presenting disfigured and occluded faces upright, upside down, measuring the index, the ERP index of the face inversion effect, and see whether there is a stronger modulation of that effect in non-disfigured faces versus disfigured faces, because in disfigured faces there would be all, regardless of whether they are upright or upside down, you would expect already an interference with the configurable processing. So that's something we are trying to do in the future now. So that is in this year. I hope if my teaching allows. Okay, I'm finished. Thank you very much for that.